Hi friends, I am Dr. T. Venkateshan, Professor, Department of Electrical and Electronics Engineering, K.S. Rangasamy College of Technology, Tiruchengodu. In this video, we are going to discuss about the induction type energy meter. We know that energy meter are used to measure the energy, and the energy is measured by measuring the power over a period of time. An energy meter is also known as watt-hour meter. The unit of power is watt and for time we used hour. So the unit of energy is watt hour. The energy meter measures the amount of power consumed by the electrical product. The working principle of energy meter is similar to the single phase watt hour meter. Both in any appliances are working in electromagnetic induction principle. The construction of single phase watt hour meter is also almost similar to single phase induction type wattmeter. The pointer and spiral spring are replaced by wheel train mechanism for summing up the total energy consumed, while the damping management is replaced by braking management. So we know the single phase energy meter. This is the figure of a single phase induction type energy meter. We are using in olden days, but nowadays the digital energy meter is available. Okay, this figure shows the construction detail of single phase energy meter. It have two electromagnet, upper and lower electromagnet. The upper electromagnet is energized by pressure coil, and lower electromagnet is connected the current coil. In between these two electromagnet, one aluminum disc is placed by using the spindle, and also one arrangement and the braking magnet. Here the permanent magnet we are used. The energy meter has four main parts: driving system, moving system, braking system, registering system. So in driving system, the electromagnet is the main component of the driving system. It is the temporary magnet that is excited by the current flowing through its coil. The core of the electromagnet is made up of silicon steel lamination. The driving system has two electromagnets. Two coils are wound on the series magnet, and this coil is called as a current coil. This coil has very few turns. It is called a series magnet because it is connected in series with the line. Whereas an shunt magnet, we have a pressure coil, and this pressure coil has a large number of turns as compared to the current coil. It is called a shunt magnet because it is connected in parallel with the line. The coil of the shunt electromagnet is directly connected to the supply and hence carries a current proportional to the shunt voltage. The center limb of the magnet has a copper band. This band are adjustable. The main function of the copper band is to align the flux produced by the shunt magnet in such a way that it is exactly perpendicular to the supply voltage. Next, moving system. A rotating aluminum disc mounted on the spindle between the two electromagnets will rotate in the magnetic field. The speed of rotation of this aluminum disc, which is proportional to the power. If the more power is applied to the instrument, then the speed of the rotations will increase, and if less power is applied, the speed of rotation will decrease. That means the load is increased, the rotation of the speed of the aluminum disc is fast if the load is reduced. If there is no load, the rotation of the aluminum disc is stopped. Suppose less load, the speed of the aluminum disc is less compared to higher loading. Next, the eddy current is induced in the disk because of the change in the magnetic field. The eddy current is cut by the magnetic flux. The interaction of the flux and the disk induces the deflecting torque. When the device consumes power, the aluminum disc starts rotating, and after some number of rotations, the disc displays the units used by the load. The number of rotation of the disc is counted at particular interval of time. The disc measured power consumption in kilowatt hour. Next, braking system. The permanent magnet is used to reduce the rotation of the aluminum disc. The aluminum disc induces the eddy current because of its rotation. The eddy current cuts the magnetic flux of the permanent magnet and hence produces the braking torque. The braking torque opposes the moment of the disc, thus reducing its speed. The permanent magnet is adjustable, due to which the braking torque is also adjusted by shifting the magnet to the other radial position. Next one, registering system. The main function of the registration or counting mechanism is to record the number of rotations of the aluminum disc. The rotation is directly proportional to the energy consumed by the loads in a kilowatt hour. The rotation of the disc is transmitted to the pointers on the different dials for recording the different readings. The reading in kilowatt hour is obtained by multiplying the number of rotation of the disc with the meter constant. Next one is creeping. Creeping is in the energy meter is the phenomenon where the aluminum disc of the energy meter keeps rotating in the absence of the current through the current coil. Thus, the energy meter records energy even when there is no current flow through the meter. Okay. For example, there is no load. Okay, no load. Suppose we put off all fan, light and every electrical appliances, but the energy meter will rotate. Okay, this one is called as a creeping. Okay, we should avoid this creeping to excess charge of the consumer. Okay, in other words, the creeping is a kind of error that happens when the voltage is applied to its pressure coil, but the meter is not connected to the load. That is, there is no current through its current coil. There are various reasons for creeping in energy meter. Some of the reasons are electromagnetic interference, excessive frictions, vibration, stay magnetic field and faulty connections. In the light load conditions, the creeping increases the speed of the disc and causes measurement error in energy meter. The excessive friction causes a creeping error. Even though the driving torque is absent at no load, the disc rotation is caused by the additional torque provided by the compensating vane. Prevention of creeping in energy meter. The creep in the energy meter causes inaccurate billing and financial loss. Therefore, it is a must that there be no creeping in the energy meter. The aluminum disc of the energy meter should not rotate at all if the load current does not pass through its current coil. We can prevent creeping in the energy meter by drilling two diametrically opposite holes in the disc of the energy meter. As shown in the figure, there are two holes diametrically a hole at the corner. As shown in the figure, the green color dot is the hole. Okay, when the hole reaches at the edge of the pole of the shunt magnet, the rotating disc comes to rest. Thus, the disc can take only half a rotation and creeping is limited. This is my reference website, and thanks for watching. Keep learning and growing. Thank you. Thank you very much.